Yes, so good afternoon, everyone. This is group CSG4 from Makerere University, and we are working on an AI-driven evaluation system for rhythm and message quality in music production. And it's a group comprised of 4 people. That is I myself, Katochi Bilige Agathon. We have Opio Philbert, Kakembo Boniface, and Batuka Samuel. Yeah, so basically, in Uganda, per se, because that is what we used as our use case, very many artists, most importantly, these that are not under record labels. Record labels are companies that take on artists, suffer with predicting whether their song will be a hit or not. So that's where we come in. We are trying to come up with a system that predicts whether a song will be a hit or a flop. But not forgetting that these have been existent people. They're already comrades that have already tried to come up with such systems. And what makes ours different is currently all systems end at prediction. These systems are going to give you a prediction. For example, there is neural forecasting. Neural forecasting is being done currently, whereby they use machines, fMRIs, to kind of predict or whether a song will be a hit based on a person's emotions. But for us, we are saying, let a system not only stop on predicting and giving a person a percentage, but let it also give a person recommendations. Okay? Let a system recommend on which aspects of a song a person should improve to make it a hit. Okay? And that's what our system is doing. Next. Yes, and yeah, so this is what we've prepared for you, as you're going to see as we proceed. Yes, so as we said earlier, for the music industry, very many songs are uploaded each single day. And basing on the various aspects of a song, we as a group believe that rhythm and message are the two most important aspects of a song that should be analyzed rather than wasting resources on trying to analyze all the aspects that exist out there, as you're going to see in our next slide. So a song comprises of danceability, variancy, energy, tempo, all those. But then for us, as you can see there, it's evident that, and based on the research we made, it's evident that rhythm and message take up the most percentage as regards to what speaks to people and what people really resonate to. Yes, so currently, when you look at the systems that exist, we identified 3 shortcomings. Number 1, we look at the overwhelming systems and complexity. In this regard, we talk of the current systems evaluate, sorry about that. So the current systems evaluate so many features, and as we said, most of these are not necessarily important. Okay, so we are trying to reduce that. We are only going to look at 2. Secondly, all systems lack actionable guidance. They're going to give you a prediction percentage, but they won't tell you on what to do next. That's where we come in. After predicting, we want to recommend on aspects that can be improved. Number 3, superficial analysis. We are trying to avoid analysis that kind of confuses the user. Yes, let's proceed. Okay, thank you. All right, let's have the next presenter.
So there's a lot of inconsistencies in determining how the success of music can be basing on the song itself and production part. So there's most of frameworks that were already established basically more of traditional ways of doing things, whereby at times we lack automatic evaluation frameworks. So we need to interpret and set up artist-friendly systems that can do this. Next. Our main AI-driven, the success of a song is basically on the message and the rhythm it contains. So specific objectives could be extracting comprehensive rhythmic features, analyzing lyrical message content, constructing a well-curated data set, then developing comprehensive machine learning prediction models with also recommendation engines that validate system performance. Next. So we are looking at how our literature review would align and arrange song science. And that was in 2019. That was by Patchett and Roy. Then 2017, we had real implementation of convolutional neural network based rhythm analysis. Then we went ahead advancing at accuracy of the features. That was around 84. Then now 224, we came up with a research of danceability as one of the key importance for heat evaluation. So the insight here is like portraying what a rhythm and a message do, and we are showing that they dominate. Next. So this is how our research gap validation table shows, whereby we looked at the aspects, the literature, and what we are contributing to. We looked at features taking 22, 25 to 50 of the literature. Then our contribution looked at the rhythm and the message. We had the depth. Then this is a bit shallow. Then for the contribution, should look more deep into the song features and the musical content. We also had a prediction plus the recommendation. Then we look at how transparent and flexible the system could be.
I will take on from where my colleague has stopped. Basically, the first thing the user does is to upload their audio lyrics, and then it is pre-processed in two actions, whereby there is a rhythm analysis using Librosa, then also the message analysis using natural language processing. After, we proceed to the future integration, and then the machine learning prediction models, which are genre specific. Then we analyze the gap, and the recommendation engine proceeds to the visualization dashboard. Yes. So now here we have the pie chart for the genre distribution among hip hop, rock, R&B, and pop music types. So we have the hip hop taking 10.5%, the rock 21.1%, R&B 31.6%, and pop 36.8%. We used a data set of 15,000 to 30,000 songs, and using the timeline between 2015 and 2024. The metrics or the engines we used to get our features, we used the Spotify API to determine the audio features and popularity of the songs, the audio. Then we used Genius API for the lyrics and annotations. We also used Billboard to determine the performance of the different charts. Then we also used the YouTube API for engagement metrics. Yes. Whereby the success criteria, there are 40% hits, 40% non-hits, and 20% for the validation. Yes. For the feature extraction, there is a total of 55 to 75 focused features versus more than 150 in the comprehensive systems. Focusing on the rhythm features, we've got the tempo, beat strength, groove quality, the danceability, that's the energy and rhythmic patterns. We've got the syncopation, temporal stability, and genre-specific conversions. Yes. For the message features, we've got the sentiment polarity, thematic coherence, narrative structure, emotional resonance, the message clarity, and vocabulary complexity, and the readability. Yes. So when we come to the machine learning models, we've got our training strategy composed of 70% train data, 15% validation, and 15% test. Then we use the Bayesian hyperparameter optimization 5-fold cross-validation as well. For our performance targets, we got F1 score of greater than 0.78. That is our target for the F1 score. Then the AUC ROC, we have to get a greater than 0.82. Then for the processing, we need less than 2 minutes track for the song upload, for the audio file which is uploaded. Then for our input layer, the features are 55 to 75 dimensions. Then we use XGBoost/LightGBM, where the assembled trees, the features, we have feature implementation, nonlinear, and interpretable for all the different genres of the pop, hip hop, R&B, and rock. So the output finally gives us whether it's a hit or it's a non-hit. The input layer, those are the feature dimensions of 55 to 75 dimensions. I would like my colleague to proceed from that.
Under our recommendations, our project, it does the gap analysis. Now with the gap analysis, the user's track is compared against the gym benchmark. It compares the user's track, the benchmark. Now the priority calculation, it also does priority calculation, whereby the system calculates the priority based on the deviation from the benchmark, then multiplied by the future importance. Another thing under the recommendations, it does the categorization. Now with categorization, recommendations are grouped into critical, importance, or important, or suggested actions. And another thing under recommendations, it does the template generation. It generates a template which is specific, actionable, and suggestions are also created. Now from the example on the side, if the current tempo or the template is 95 BPM, but the target or the pop optimal is from 110 to 130 BPM, the action is to increase the tempo to 115 and 120 BPM, which is predicted to result in an impact of 12 points in score. Yeah, judging from the example we have there. Now, next slide. Now, this research matters because of the following. As stated, it matters because it addresses critical gap in the music evaluation tool. It has a focused approach, deeper insights than the comprehensive systems which have been already existing. Actionable recommendations which enable the artist to improve on his already produced demo or the song. It does the validation production stage, independence evaluation. It advances interpretable AI in creative application. Okay, this is about why this research matters. Now, for the next steps or the further activities to be done in this project, there is finalizing the dataset collection and the infrastructures, begin a rhythm and message feature extraction, develop a baseline prediction module, narrative development and testing. Those are the future things or the future activities to be carried out in this project. Thank you so much.
So this is a walkthrough of our prototype. And this is the interface, how it should all look. Here we are having three distinct categories of features. Let's say vocals, beats, and a full mix, in a way that catering for the different users. Let's say the songwriters, producers, and the artists themselves. So in simple terms, someone selects the category they want, then uploads, or let's say for the vocals, as a songwriter can decide to record, can decide to upload the recorded file, just like this. After that, checks for the for the for the for the prediction of or for the success score, whereby the model analyzes behind the scenes, then gives the prediction score result, and after that, the user could be in position to see the metrics. Let's say the success score was 29%, the energy is low, clarity is not was 90%, something like that. So that's for recommendation, it could be easy for the user to really identify where the weaknesses of the song could be or whether the strength of the song could be. Thank you.